Hello everyone. In this video we will continue talking about multiplying and factoring of quadratic expressions. Okay, so what I'd like to teach you is the one rule that you can use to factor every single quadratic expression. Now you may have learned some other tricks or tips or shortcuts, various rules and formulas, so if you like those then feel free to keep using those, but what I wanted to do is just give you a very simple method that will work every single time in case you didn't like or are not familiar with other ways to factor. Alright, so here are those steps to this process, and then we'll do a variety of examples to practice this. First, you want to write your quadratic expression in the form ax squared plus bx plus c, and you also want to make sure that the greatest common factor for all three terms is 1. If it's not, then that's your first step. You want to factor it out, and then just deal with whatever's left. Okay, then you're going to multiply a and c together. Then we're looking for two numbers, and I've called them d and e, that multiply to equal ac and add to equal b. Okay, and then we're going to rewrite the middle terms in this expression. Right? And then we're going to factor out the greatest common factor from the two, or kind of this rewritten expression, breaking it up in parts. Alright, I think we'll do an example as we go along and kind of work on this, and I think all of these letters and variables will fall into place when you see how this works with real numbers. Here's a little picture that I've made for you of kind of an organization method I use with this type of factoring. So I make a big X, and then I record what the numbers are here, right, A, C, and B, and then the numbers that I'm looking for, I can put those in the missing spots. Okay, so let's try it out. Factor a trinomial, x squared plus 10x plus 16. Okay, so step one, it is in standard form, ax plus b, x squared plus bx plus c. I also need to make sure that the greatest common factor is a 1. So I've given you the long way to do this in the last video. Here's kind of a shortcut. Notice that the last term doesn't have an x in it, so I know that I'm not going to be able to factor out any variables. I can't factor out an x at all. So the only thing that I'm really checking is the greatest common factor of those three numbers. So, you know, if I'm looking for greatest common factors of 1, 10, and 16, I think it's pretty clear that the only thing that goes into 1 is just 1. You know, we're only looking at positive integer type numbers here. All right. So right away, no matter what 10 and 16 are, okay, in this case 2 and 5 and a bunch of 2's, there's nothing that I'm going to be able to circle that's common to all of these other than a 1. Right? So if you have something like a 1 for A, B, or C, that's a nice shortcut. I know right away that the greatest common factor is definitely a 1. Okay, it can't be any bigger than your smallest number. Okay, so now I want to go on to this method. So the next step is to find A times C. All right, so I'm going to make this X, and I need to find A times C. Well, A is 1, and C is 16, so multiplying, that gives 16. Then I need to find B, which is a 10. Okay. And then I'm looking for two numbers. I've called them D and E, right, or you can skip that if you like, but two numbers that multiply to be 16. So D times E is 16, and when I add them, I need to get 10. Alright, so you want to just start making a list, and I like to work with the multiplication first, and then see which options add up to be 10. Alright, so start with 1 times 16, right, and then think about adding them. That's not 10, right? 2 and 8 make 16, 4 and 4, and you can stop your factors if you arrange them this way. They're going to kind of wrap around here, right? We're going from the smallest to the largest, 1 all the way to 16, and you can stop when you kind of reach that halfway point. If I was to make the 4 any larger, like say a 5, then the second number would need to be made smaller to compensate. All right, and there's nothing smaller than 4 that's kind of between 4 and 4. Okay, so then I need to add these up and see which one gives me 10. And only one of these works. Okay, we have 2 plus 8 is 10, and 2 times 8 equals 16. Alright, so now what I'm going to do is rewrite the original expression, and I'm going to leave the first and last terms, but in the middle, instead of writing 10x, I'm going to use the new numbers that I found and write that as 2x plus 8x, and still plus 16. Okay. Now I'm going to look at the two pairs of numbers, right? Two pairs of terms, and take the greatest common factor out of each one. Right? So what can come out of x squared and 2x? Well, looking at the numbers, 1 and 2, I can't take anything out other than 1, but looking at the greatest common factor of x and x squared, that would be an x. Right? And then what's left? That would be an x plus a 2. All right, how about 8x plus 16? Well, I can take out a positive 8, and that's it. All right, and what's left? X plus 2. All right. Now, if you need a review of how I'm getting these numbers, go back and watch the first video, which would explain how to find the greatest common factor of something like 8x plus 16. Okay, and then notice what I have now are actually two large terms. These are multiplied, so that's a term. Here's a term, and then they're connected by a plus sign. Now notice, if you do this correctly, you should end up with a pair of matching parentheses, and that whole parentheses can be factored out of each of those terms. So I'm going to take that out, x plus 2, and then look at what's left. Well, in the first term I have an x, and in the second term I have an 8. Okay, and put parentheses around that. And this is a nice way, this factors this for us. This factors into x plus 8 times x plus 2, and that's the answer. Right? Now, to check this, use FOIL on that, and make sure that you still get the original problem. Okay, let's try another one. Actually, before I do that, let me mention as a shortcut here, if the a is a 1, then you can take kind of a shortcut, and once you find your two numbers over here, you can just jump right to the answer. Okay, it's going to be x plus 8 and x plus 2, and you can kind of skip all of this middle work here. If the first number is not a 1, then we do need to go through that whole process. So that's why I wanted to show you all of the steps on that previous problem. Alright, so let's try the same thing. Multiply a times c. Oh, I'm forgetting a step, right? Okay, make sure that the greatest common factor is a 1 here. Alright, so look at 3x squared, 6x, 24. There's no x in the last term, so just look at the numbers. And it looks like we can factor out a 3. So doing that, we're left with x squared minus 2x minus 8. Okay, and then this is the part we want to focus on. Ignore the 3 until the very end, and you're just going to factor x squared minus 2x minus 8. Alright, so a times c is 1 times negative 8, which is negative 8. And then b, the middle term, is negative 2. So we're looking for numbers that multiply to be negative 8 and add to be negative 2. Right? Well, first of all, notice if they're multiplying to be negative 8, then I need one positive and one negative. So keep that in mind. So what I'm going to do is just start with the positive versions and then realize that one of them can be made negative. Right? So I've got 1 and 8, and I always start with 1 and the number itself. Okay, and then make the 1 bigger from there, and the 8 will get smaller. Alright, so then I'll go to 2 and 4. Oops. Alright, and that's it. If I try to go to 3, it's not a factor of 8. And if I go to 4, then I'm back to that combination that I already found, 4 and 2. So again, we're stopping at the midway point. All right, and we've got all of the factors now. Okay, so now one needs to be positive and one needs to be made negative. I'm not sure which one, but I know that this needs to add up to -2. All right, so if I did 1 plus -8, that doesn't work. -1 plus 8 doesn't work. If I do -2 plus 4, that gives me the right number but the wrong sign. So I want to flip-flop that and do 2 plus -4. Right, 2 and -4. All right, so we can take a shortcut here since the a was a 1, and I know that this is going to factor as x plus 2 and then x minus 4, and then we also write the 3 that was part of the greatest common factor. All right, so what we want to end up with is an answer of all of the factors that when you remultiply, you end up with your original problem. All right, how about this one? 3x squared minus 4x minus 15. Looking for the GCF, I see that 3 and 4 don't have anything in common, so there's nothing I'm going to be able to factor out of those other than a 1. All right, so this is our first example where a is not a 1, and we can't factor to make it a 1. Okay, so same method. And a times c is 3 times -15, or -45. And then b is -4. All right, so factors of 45 that add up to be -4. So 1 and 45, not 2, 3 and 15, not 4, 5 works, 5 and 9. All right, not 6, not 7, not 8, and then by the time we do 9 here, it's just going to be back to 5 again. All right, so we've crossed over, and that's the complete list of integers that divide into 45. Okay, so one of them needs to be negative, so which one of these will add up to -4? All right, well, it's going to be this one, as long as we make the 9 a negative. So 5 and -9 add up to be -4, and they multiply to be -45. Okay, so let's go on to the next step. Copy down the first and last terms, but then instead of -4x, I'm going to rewrite that as 5x and -9x. Okay, and now I want to find the greatest common factor for the first two terms and then the next two. All right, so first ones, I can't take anything out of 3 and 5, but I can take out an x. And what's left is 3x plus 5. Okay, the next two, if you see a negative in both terms, then go ahead and take that out as well. All right, so we're going to pull out a -1 as part of the greatest common factor. And then what else is part of it? Well, also a 3. All right, and then what's left? 3x, and then a positive 5. All right, so I'm using, again, the method for finding the greatest common factor, but as a quick check here, just make sure -3 times 3x is -9x, and -3 times positive 5 is -15. All right, and then if we do this correctly, the parentheses should match. That can be factored out of each term. And then what's left is x minus 3. The x here and the -3 here. And that's the answer. All right, we'll try another one with larger numbers. So you may also be recalling some other methods that you've used for this. There's one where you kind of just guess at this. You write your parentheses and then try to think of things that go in each spot. There is some trial and error involved with that. And I think that this method has a little bit less guesswork in order to find the correct factorization. Okay, so same thing. Look for the greatest common factor. So 33, the only things that go in are 3 and 11, and neither of those is a factor of 10. All right, and 10 doesn't have an x in it, so I can't pull out any variables. So unfortunately, this is the greatest common factor is 1, so we're going to have to deal with these large numbers. So multiplying, a times c would be 140, and then b is a negative 33. Okay, so I need two numbers that multiply to be 140 and add up to be negative 33. All right, so let's go with 1 and 140, 2 and 70, and then we just keep going from there. Not 3, 4 would work. And here's a, you can do some little shortcuts. So I'm doubling the 2, so I'm going to have the 70. Okay, so 4 and 35. 5 works, and 5 and 28. Okay, and I think this may actually be the one we want, so let's stop there. Now notice 5 plus 28 is 33, and that's close, but it's the wrong sign. All right, so how am I going to get this to be a negative 33? Well, if both were negative, that would work. And then notice a negative times a negative does equal positive 140. Okay, so that will work. Okay, so we have our numbers. Move on to the next step. 14x squared, positive 10, and then in the middle, instead of negative 33x, I'll write that as negative 5x and negative 28x. Take the greatest common factor out of 14x squared minus 5x. No number will factor out, but I can take out an x and get 14x minus 5. All right. And again, if you have a negative like this, I'm going to take that out as well. So a negative 1. And then the greatest common factor of 28 and 10 looks like a 2. All right, well, what's left? 14x. And then since I took out a negative, this is now going to be a negative 5. So think about remultiplying. Negative 2 times what makes positive 10? It would need to be a negative 5. All right, so the reason I took that out was so that I ended up with these two matching parentheses. If I didn't, I would end up with negative 14x plus 5, and then that does not match the first parentheses. All right, so now I want to factor that out. 14x minus 5, and see what's left. And what's left is this x minus 2. All right, so the factored version is x minus 2 times 14x minus 5. Okay, well, we'll stop there, and I will do a few more examples. In the next video, I'd like to do a few binomials. So far, we've mostly worked with trinomials.